ขึ้นเลยนะครับถ้าเกิดว่าติดอะไรมาถามตอนหลังก็ได้นะครับได้ยินไหมครับได้ยินไหม
Is everyone in? Okay, so good afternoon, everybody. Hopefully you can all hear me. If you can't, there's lots of seats here. I think I speak loud enough, but if you need more, move up. I'll try and keep this to 1 hour, less than 1 hour. So might skip some things and just go to solutions that you can sell, or maybe apply. Is everyone here in new applications or aftermarket? New or both?
Both.
Both. Okay. So this applies to both, and I'll obviously. So I'll skip that. Okay. So if we just do a comparison between fixed speed and variable speed, right? I think some people may have seen this slide. In a normal application, if this is a 75 kilowatt motor running at full flow, maybe you absorb 72 kilowatts of power. If you wanted to halve this flow, and get half of that value, typically a customer would shut the control valve, or something in the system will slow it down. So in that case, get the half flow. As you can see, we keep changing the system. We keep changing the system curve, and to get the half flow will be 35–36%. You see here the power is 52 kilowatt. So I have lots of customers. When I meet them, they said, "Oh, we can save power by reducing the flow. You'll save a bit, but if you did the same with the VFD, so you leave the valve fully open, and instead of changing the system curve, we're going to change the speed, the pump curve. Then to get to the 50% flow, instead of 52 kilowatt, you're at 22.
Oh.
So the savings are exponential.
Yeah.
But the problem in the market is some customers have very cheap energy and they don't care for them. And maybe 30 kilowatts is not enough. So we can't always sell energy, especially a power station. Power stations, they don't care.
Yeah.
But power stations have different attitude. They have overall plant efficiency. You were saying that you do pipelines. So maybe pipelines have energy costs because they have to buy their electricity. But other one is tank terminals. Tank terminals, they're not concerned about electricity, but they can be concerned about loading times.
Yeah, correct.
How fast.
Yeah.
Right? So whilst this is the best slide to show energy savings, it doesn't tell you anything else that we can do with the pump smart, with a variable speed drive. So these benefits, you can get that from any variable speed drive. So we have to compete with the Pump Smart. We compete against ABB, even though the Pump Smart for us is an ABB product.
Yeah.
We still have to compete with ABB. So we can't just use these examples of how we are a benefit. One thing we can start to look at is better process control. So in all the applications that we're doing, we look for what is important to the customer. So the tank terminal, how fast can I fill the boat? And then we angle the solution towards that. Because for them, that can save money. In the pipeline, maybe the pipeline sometimes have problems that many users, so more than just one user, they're not in control of the pipeline, the main pipeline. They have to inject into it. And then maybe they share it with other facilities or other pumps or something like that. So they're not always in control, and maybe they pump different products. So the system resistant curve changes based on the product they're pumping. Actually, pipelines and tank terminals, arguments are very similar, because it's always about how fast can we deliver the product. So with the Pump Smart solution, we consider more where the pump is operating. Right? A normal selection, rated duty, is going to be as close as possible to best efficiency point. But very rarely, especially in tank terminal applications, very rarely do they ever operate here. That's at full speed, best efficiency point. Usually, especially in the tank terminal, this condition is when the supply tank is very low. So then it's the maximum amount of total dynamic head. Also maybe the most viscous product. So the friction loss is the highest. But most of the times, the tank terminal will operate down here, run out condition. So a recent example, we had a customer in Singapore, and they've been using Danfoss variable speed drives forever. All their variable speed drives are Danfoss. But the operator continuously tells me that they have suction, well, they have cavitation problems. And he always blames the suction.
Yeah.
But I explained to him, it's not suction, it's just not enough back pressure. It's the opposite. So they hear the sound, you know, the noise in their terminal, and they don't like it. So they think they need to put more liquid in the tank. But that actually just makes this worse. We just keep pushing further and further down. If you remember from this slide, I've lowered the speed. See the pump curve? This is the original. The maximum flow is higher. Once you slow the pump down, the maximum flow is lower. So again, at that tank terminal where they're using Danfoss, they're not concerned about where the pump is. They start lowering the speed when the tank level goes down, but it just makes this condition even worse. So they are so far off the end of the curve that the curve doesn't exist. So they get cavitation. But they blame the suction pressure. But really that's the run-out condition. At that point, you cannot push enough flow into the pump to satisfy the pump flow rate. It's just well beyond. Actually, that is more destructive. This can be more destructive in the long term than running here. Because running here, a lot of times the calculations are a bit conservative. You can probably run there longer than you say. As long as the liquid is cold, maybe it will be okay. I have lots of applications where the customer runs here all the time. It's not good, but the pumps sometimes survive. But if they start running here off the end of the curve, usually that's when we get shaft failures and things like that. High maintenance costs. So again, it's understanding where we are. So these are the two things that we really look at compared to a variable speed drive, the normal one. One other thing is we have challenges where customers say, we put all our logic in the DCS or the SCADA system. We do everything in there, in the control room. They can try, but they will never do what we can do. We have over 20,000 hours worth of coding. For them to achieve what we do in this variable speed drive, they would need to do this. But they need to be experts as well, but they're usually not. The people who do the coding in the SCADA system are computer people. They're not mechanical engineers. A mechanical engineer might tell them what to do, but they still do it their own way, in the way that they're used to. ITT have done a lot of research and development, so sometimes this is an area where we can save the customer. We can say, if it's a new plant, they need to do less work to get this pump smart in. And we can help you understand how many hours they can save. Because I have a good understanding of how many hours it takes to code a PLC. When they code a PLC, often it's very simple, whereas ours is very complex but very easy to get in there. So it actually saves them time. As a comparison, I think we could code a normal tank terminal arrangement, maybe take 300 hours of coding. If the customer uses our system properly, maybe they can do it in 10 hours of coding. Start, stop, that's it. On and off. Everything else can be done by the pump smart. So obviously, these are all the things that we do different to a normal variable speed drive. The big one is the sensorless flow. So we calculate the flow without the flow meter. So again, maybe we can save the customer money on that, on the flow meter, especially if it's a big pipeline. The other alternative is sometimes the products are all very different. So we can handle that too. But because we know where the flow is, our multi-pump control is very, very good. We, rather than making two pumps run at the same speed, we'll make two pumps run at the same flow. It's very good when maybe one pump's new and one pump's old. If you have customers with lots of mechanical seal failures in multi-pump systems, it's because of the way they're controlling, even on fixed speed. Two fixed speed pumps are the same as two variable speed pumps running at the same speed, it doesn't matter. Often they'll replace the mechanical seal on one pump and then soon after the other pump will go. It's probably because they overhaul the pump at the same time. So that overhaul pump is now stronger than the old pump. But different system conditions can make a difference too. Compared to even 5 years ago, variable speeds are nowhere near the same as they used to be. They are so much more advanced now. They use better processors, and we can do far more calculations in the variable speed drive than we could with the older model. Yes, this one. You can see we only came out in 2016. It's only been 4 years. So 5 years ago we were using this one. The computers are not even similar. This had like 500 kilobytes of memory, half a megabyte. This one here is almost unlimited, just whatever we need. So the other big thing is our pump protections. And again, we have a few examples where customers have used a normal variable speed drive to try and, maybe that pump says it's got dry run protection or something, but it doesn't actually work. And the reason a lot of the times is a regular variable speed drive may look at current or torque. ITT consider the pump curve, and we look at current, speed and torque all at the same time. So here we map where the acceptable pump operating region is for every torque and every speed. Whereas a regular variable speed drive, maybe they use 50% torque. So when it's 50% torque, they will dry run. But you can see here that if you're at a lower speed, 50% torque is acceptable. So then the customer has a problem and they decide we need to lower that value. So then they lower the value to 25. So they can start operating here, between these two speeds. But the problem then happens is that sometimes you get a dry run and you could be at 50% torque. So now they have it set it for a full speed low enough. Now if you running a pressure control system, if you start dry running, what happens to the pressure? So if you can't push any liquid in there, what do you think happens to the pressure? It goes down. So what's the first thing the pump's going to do? Speed up. So you can see where I'm going. So if you have a pressure control system and you start dry running, you are going to hit maximum speed, 100%. Because the control logic will say, I've not got enough pressure, increase my speed. So you will operate here. So many times we can show a customer that, using just torque is not going to help, because as soon as then they lower, they trip again because they're below 50% torque. So they need to compromise. Some variable speed drives might allow you to put 2 or 3 points, different torques versus different speeds, but it's still a guess. With the Pump Smart, we don't guess, we know. Through affinity laws, we calculate. Also, our torque response, the reason we use the ABB ACSA 80 is this torque value is very accurate. So because that's accurate, we can do this accurately. Also, we can accurately tell the customer that they're at minimum flow compared to dry run. We can tell them the difference. Acceptable, minimum, dry run, and run out. So we can tell all three bad situations. And we can send that to the customer as a warning, a fault, anything they want. So they can change the way they operate. This slide is very important in a way, especially for pressure control, because it shows here, whilst regular variable speed drives will change speed, the problem that happens is when the flat system curve comes to a flat pump curve, a very tiny change in speed can have a very big change in flow. So you could do a tiny change in speed and all of a sudden be at zero flow. The Pump Smart, we're using torque, so the same curve is a very strong gradient of torque that's easier for us to control. We can give you here, here, here very easily. Whereas on this one, you'll be swinging over the place. So process stability is something we can achieve very well, and we have quite a few examples. This is one here, where the process was up and down after the Pump Smart, very, very flat. This is pressure. Actually, it's even better than that now. This is early stage tuning. And this flow is going up and down all the time. Sometimes there was 1, 2, or 3 pumps running, but we can keep the pressure very stable. And it's all because of torque. We control the torque, not speed. If you're trying to explain to a customer, maybe the easy way to say is, instead of controlling speed, we control flow. That's how I keep it simple. I won't do that slide because it's complex, but it's exactly what we just covered. So we only need a little bit of information to be able to do everything. Some new benefits that we've got, and I'm starting to find applications where these are very useful. Minimum flow bypass valve control. So if a customer needs a bypass valve, we can take control of that to open and close it. When the flow gets to a certain amount, we close it. When it's not enough, we open it. So we can take control of that. Again, that is how we can stop the customer spending time coding a SCADA system. It's one area where we can save. The other thing that I'm starting to understand new ways to use is the best efficiency point. Okay? This is probably, I think this is going to be the next unique thing we can do for customers if we understand how this works correctly. And it all goes back to that very first slide where the customer runs off the end of the curve past the best efficiency point. We can now tell them how far they are. And it becomes very relevant for tank terminals or ship loading or transfer, all this pipelines. Pipelines use this a lot. It was difficult to do on these low voltage, but now we can because of the new technology. I'll show you how we use it. We also calculate head now as well, rather than just flow, so we can tell the head. Actually, the next software version, we will be able to control pressure without a pressure transmitter. Or head, without a head pressure transmitter. So that's going to be good for some applications. Twin screw and PD pumps, we do a few features. They're more custom applications. It's just some details on the hardware. So it's standard ABB hardware. Any option the customer wants, we can include. The medium voltage is customized. I need to make this clear. This is not very clear to someone, even internal. The PS220 low voltage is only available on ABB ACS 880 at the moment. We are looking at another brand, but it won't have all the same features. This will always be the best product in the low voltage because the torque is very accurate. No other brand can do it accurately, so we can't do the same control. But medium voltage, we are okay with almost any brand, and we do. Actually, less than 50% of our medium voltage drives are ABB. We work closely with ABB, and if the customer has no preference, we will use ABB most likely. But we also now, if you look in ePrism, you'll see pricing for Toshiba and Rockwell. But if you want Siemens, you want Schneider, doesn't matter, we can do it. Because all the pump smart logic sits in the separate PLC and integrates into the cabinet. We do need to specify the variable speed drive. So the customer will have a specification, ITT has a specification, together we can get a pump smart. Because we need good torque feedback from the variable speed drive. That's how our logic works. But many medium voltage drives, the good ones, they will have that available. But in Rockwell, for example, they have a PowerFlex 6000, I think it's called, which we can use, but we can't use maybe the 3000 series because they don't have good torque. And it's a cheaper drive, it's lower cost. So we do tend to need the more premium drive. Now you're saying you do pipelines. These two are our biggest pipeline customers. Actually, Blue Racer in the US is now standardized on Pump Smart. So anytime they need a new pump, they buy the pump and the Pump Smart from us because the solution is so good. So it's the hardest bit is getting in the first place. Once we get in to a customer, they will usually keep buying. And so one of the things I work with CM Raj in Thailand, because Thailand is one of the target countries, is to get a good installed base growing in Thailand. So some applications are easier than others. So I'll work with the management to figure that out. This is Vopak in Singapore. So they had 900 kilowatt motors, three pumps. This was an upgrade. So this was an existing terminal. They increased the size of the pipe and they wanted more flow because they want to fill the boats up faster. So they went from 1,500 meters cubed per hour to 2,500. Changed the pump. But we ITT, we're very helpful for them because we managed to keep the same footprint and the same pit for the vertical pump. Other brands wanted a deeper pit. It means they had to dig out the hole. We didn't need to do that. But one of the challenges there was 21 different liquids. Every single one different properties. Some are heavy, some are thick. Very, very tricky. But we could deal with it. Also, reliability was a concern, and the noise. They were getting a lot of noise with their old pump. What we ended up doing was we automated the flow control valve, this valve here. We did pump protection, and we keep the pump running as efficient as possible. How that works is like this. That was their system curve that they gave us. selection meant that if they had this system curve, most of the time the variable speed drive will follow the BP line, the friction resistance versus the system curve versus the pump speed curve. So in that case, they will see speed reduce. But they also had a floating roof. So if you've got any floating roof applications, the problem was down here, if they wanted 400 meters cube per hour when they raise or lower the roof, sometimes it was difficult. So when that happened, we used the flow control valve to throttle back only at the last speed. So this system curve was for low tank, but the problem was the system curve for high tank. So you can see we're off the end of the curve, intersection point. And here, this happened during commissioning, was they wanted to lower the roof. So that's when the roof is going to hit the floor. So they need to make sure it's going slow. We were at 1,000 meters cube per hour because the intersection from a high tank, which was on, we were pumping from the one high tank to the low tank or something like that. Actually, even when they raise the roof, they need to do it slow. So we were doing 1,000 meters cube per hour because the system curve intersection with the pump curve was down here. So the only way to do it was to use the flow control valve to bring the flow back. At any of these other points, when we're off the end of the curve, we can use the flow control valve to push back and land on the best efficiency point line. So overall, this pump, no matter what the system conditions, no matter what the liquid, will run the best efficiency point to the minimum speed, and then when they still want to go lower flow, we reduce with the flow control valve. So the customer can choose whatever speed, whatever flow they want. They just select flow. And in all cases, they want a high flow until they settle the roof when they want this flow. So they had two choices, but they can choose whatever they want. And that one's the most successful application we have in the region. That's in Singapore. There's 3 of them. We've been running since 2015, 16. They have had, in the last year, they've had 3 faults. The customer blames us. The pump's turned off. There's a red light flashing. When we do the analysis and we look at it, we've protected their pump and stopped $100,000 worth of damage every single time. Because they've actually had problems where they've had a valve shut and they didn't know about it and they're operating here. So we fault very fast. They find it annoying, we find it satisfying. If the maintenance, the terminal manager knew about it, he would be very happy. So sharing that around Vopak has been a challenge, but we're getting there. Proving to them how much we save. Actually, at that Vopak site, I can use this now for other sites as well as indication. I did some calculations. This was just last year alone. How much we saved them just from protecting them. We saved them at least 3 times from pump failure. We stopped their roof at least once. However, their risk is every single time. And then in terms of unloading speeds, we can deliver product to their ships approximately 3 hours faster each use from our solution. Because I can tell you, if the customer was running here, if the customer runs here, they will actually get less flow through the system, because what happens is all of a sudden the NPSH required goes up very, very high. So the flow goes up, collapses, and goes down. So the flow goes up and down. They get surging. I've got sites where I've taken video of the pressure gauges going up and down. When that happens, the time to transfer product takes a lot longer. And maybe the average is down here, 13 to 1500 rather than full flow. So keeping the pump on the best efficiency point is important for process stability and speed. So any application we can help you identify how we can do that. Now, in terms of that, that's a medium voltage one. For the low voltage, I have a customer, again another Vopak customer, but a different site, where they had those Danfoss drives. We are using the percentage BEP value, sending it to the SCADA, to the DCS, the control room, and then they can see where they are, and if they're past 110%, they will send someone out to the field to shut the valve a bit. Once they shut the valve once, they will never need to worry about it again. The variable speed drive will do the rest, increase speed, decrease speed. But it's just to push them back onto the curve from the very beginning. Because they were off the end of the curve, when they have the lower tank levels, they just couldn't run the pump very well at all. Okay. Yeah, I mean, oil tanking, we look at, see this project, we delivered 20. It's quite a lot, right? And Gould's pumps, often we sell the pumps with them. With Russia, we have some fuel, gasoline transportation, this is pipeline application. We can help customers customize a full terminal if we need to. Usually it's quite cheap for us because all our logic's already done. Is there any questions about PumpSmart? Because I'll stop on that. We're going to have some targeted customers to look for, and when you go across these applications, we will encourage you to bring it to us, because with the experience even myself and some of the others in the team have had over the last few years, we can now start to look at a data sheet and tell you how much we can save, rather than just energy. Okay.
Actually, I have one case for the fuel pipeline company, but they do the oil terminal also, and then they use a pump for the ethanol and mix with the gasoline, and then they move the tank from near to far. So the pipe is fixed. So the problem about the NPSH problem. So I recommend to use this one to them to.
So there's ways we can automate, do it automatically.
Yes, yes.
But there's also ways that if they don't want to spend that much, we can help them
They
do it
need
manually.
to fix the pressure.
Yep, yep.
Yeah,
So,
for the
so they can use, in the past, they have to calculate the flow, where it is on the curve and all this.
Yeah.
But now, on the PumpSmart screen, it'll tell you percentage best efficiency point, BEP.
Mm-hmm.
Because it tells you the BEP, that's the only value you need. You don't need to know the speed, you don't need to know the flow. You just need to know how far past the best efficiency point it is and push it back. And then they can set it and leave it. But if they change the liquid, they need to do that again. So
They just bought the PumpSmart, the old version, right? I don't know how to upgrade or whatever.
old version. Did they buy an old one, did they? How long ago?
I forgot the model. I think PS something, yes.
Well, there's PS200.
Yeah,
PS220.
maybe, yes.
You can tell by the colour.
Color.
Yeah, I'll show you. On this slide. Where am I? Here. The old one is
Yeah,
white.
I think that one.
The new one's black.
No. 800.
ACS 800.
Yeah, okay, that's that one.
Yeah.
So that one doesn't do that.
Cannot do that.
This one can. This is more computer powered. What type of customer? What's the name of the customer?
Fuel pipeline transport company, FPT.
Do they have lots of projects coming up? New projects?
Yes.
Because maybe, if there's projects coming, maybe we can put money. Maybe we can discuss. You know, if there's future business, we can look at upgrading one as a
As a complimentary.
a demo, trial, whatever. That if they're really happy with it, then they buy more in the future. Because once the customer starts using this properly, they will always like to use it. And no one else will be the same. They can look for every other brand, nothing will do it the same. The reason we can use the best efficiency point is because it tells us that we're here. If they first change the pipe and then they start operating here, they just throttle back. Now if they're here, there's nothing much we can do. All we can do is increase speed. But still, we can maybe look at the application and understand how we can use our features to be benefit to them. In Vopak terminal, their problem was they always operate here. So they will turn the pump on. They will see that they're being told you're operating at maybe 130% best efficiency point. So then they just keep throttling back until they see 110%. Now if they throttle back and the flow goes down, the speed of the pump will just increase. And so eventually we'll get to a point where the speed goes up and the best efficiency meet at a perfect point where we're happy with it. Then in the future, as the tank level goes down, the speed will decrease, but we won't go past the best efficiency point. The way, I can draw a map of it, but it follows. And as I explained to the customer, the worst time is the red line, when the tank is full. So it's the first time you operate, so you push here. And then from then on, the pump speed will do the rest.
So do we need a pressure transmitter for
If they pump the same product all the time, it's very easy. If they pump different products, that's when we need a little bit more information. So we need to know what product's being pumped, so we can amend, change our calculations.
So that means this pump smart, if in terminal, if batch controller control into the low flow, that will decrease the speed together, right?
If it's a tank terminal where there's a batch controller for truck loading,
Yeah.
yep, then actually the system curve is usually pretty good. There's no, we would consider it as almost a flat curve because the batch controller throttles the flow. So you've got fixed flows. But the speed in that case will change up and down based on the supply tank level, automatically. So we don't need, that one's very easy. That's our easiest application. The tank terminal ones that are harder are when they, like you're saying, different pipe lengths. The Vopak Banyan's problem is that the pump is fixed and they can draw from a tank here, here, anywhere.
Yes.
The friction curve changes every single time. So that's where they design for the worst case, but actually the best case causes this all the time. So they always have cavitation and vibration noises. You see here it says cavitation. They're always off the end of the curve. So every application's a little different how we can do it, but like the same customer, Vopak, but a different site. It's only a small pump. They're going to use the feedback of the best efficiency point, throttle a valve manually, and then leave it. And then the pump smart will do the rest. Increase speed, decrease speed, because we'll always give them the same flow. That's the goal. Constant flow. So yeah, your application, that's it. You just ask me and I can help.
Yeah.
I'll tell you what I need. Maybe I need the data sheet, maybe a P&ID, that's it. Piping drawing, that's it.
In case of we have a 4 truck in the same time and have a 1 pump, usually to 4 trucks, right? So what pump smart to control it, because of batch controller is not open and off and stop in the same time.
Yeah.
Yeah.
So we usually run those on pressure control. So we look to maintain a constant pressure at the road gantry, at the batch controller, constant pressure. The only problem is if the pump is sized too small for that pressure with 4 trucks, then the pressure will drop. But as soon as one truck comes off, the pressure will go back up and then it will slow down again. So most times the one pump, it's sized for 4 arms, right? Yeah, so it's usually bigger than it needs to be. Because unless you get exactly 4 trucks with exactly an empty tank, you're never going to hit the maximum rated condition. But usually the problem that we have is that once you start lowering the speed, the pump might run off the end of the curve. Because, like I said here, the problem can be that when you have a high tank level, the speed to give you the pressure needs to be lower. So here your pump's designed for 4 arms, but here it can only do 3. So when that happens, we can do tricks. One trick we can do is look at the best efficiency point and deliberately increase the minimum speed, so that whilst you'll now have a higher pressure, at least the pump is not damaged. So every application is different, but because of the new features on the Pump Smart, we can adapt a lot better. If they have 2 pumps, even better. Well, what would happen is normally we would turn the second pump on earlier. You know, I've got one customer where it's one customer at my site, they've got 3 pumps. They're meant to go 2 arms, 2 arms, 2 arms, 2, 4, 6. When the tank level on the suction is high, it'll go 1, then 3, then 5. Not 2, 4, 6. You do 1 arm, then it will jump. It'll only do 1 arm. Then as soon as it goes to 2, it'll jump to the next one, because the pump speed's lower and the maximum flow is reduced. So we can, in multi-pump, we automatically do that. We tell the second pump to come on sooner when the tank is higher. Overall, they save a lot of power. They still save power, but we make sure the pumps operate correctly. Okay. I think that was a long one, a little bit longer. I'll quickly just show you iAlert. I'm going to skip and show you some of the new features. This is our key presentation. We'll be sharing this with you. But here we have a customer who measured vibration every 2 weeks. Just over 2 weeks. They had a pump failure, but from their history, this is inch per second. They did not have many, the vibration was very low. But they had an iAlert on the pump and they were not using it, but it was there. And that was the result. So you can see they captured, same time as we did, low vibration. But they never saw this bad high peaks. This is 1.4 inches a second, this is 30 millimeters plus, very high vibration. Because of the iAlert, they were able to discover that when they have a steam supply problem, this pump cavitates because the product would get very thick and they couldn't pump anymore. So they tied together a steam-related issue to the vibration on a pump. And what that means is they can prevent that pump from failing in the same way again. Often customers do root cause analysis, and if they said the vibration was very low, every time we recorded it, the pump was not a problem. Maybe someone fixed the pump incorrectly or something like that. But with the pump, with the iAlert, we can help the customer diagnose correctly. So our sensors are the products you buy, the app is free, and then there's the website, which I'll show you that in a minute. The gateway is coming this month, although it might be a little bit longer to get to Thailand. Just found out it's going to be a bit harder to get outside of America, but we'll be able to at least let the customers know that this is the way the technology is going. If you use the gateway, you have to use the platform because the data comes from the transmitter straight to the gateway and then you can view it here. You can't view it on your tablet. There's no point having this without this. So in that regards, This is a subscription. This is going to be a subscription as well. No capital. You can't just buy it. You have to pay monthly for it. So we show this to customers now that this is the way you can grow your platform. The good thing about the iAlert is no customer needs to buy $100,000 worth of equipment straight away. They can start small and build up their confidence and build up their system. So it's fully expandable. So here is the latest specs. So we can do a little bit extra frequency, which is very useful for low running speeds. And our default settings are 60 minutes for recording the data and 5 minutes for checking. You can now change that down to 1 minute, but your battery life will go right down. So this is 3 or 4 month life. You make the sample time every minute, save a data point every minute. You will use the battery in 1 month. It's only 1 month. But sometimes customers like that for troubleshooting. Works for troubleshooting. Just to clarify, this graph is pretty good for showing you when a data point collected. Everywhere you see a dot, that's where we save a piece of data. So, if it's healthy, green, you get 1 point here, and then 1 hour later, you get another point. Save. The pump vibration can go up and down, but you get that. If the vibration was to cross the alarm warning level, you will only get the point if it crosses at the 1 hour interval. Here, this vibration goes up and it crossed the alarm. But within 5 minutes, it went down. So 20 minutes, it was up. 5 minutes later, it was below. So we don't save a data point. But here, it went above the alarm at 35 and then 40 minutes. So then we save a data point. This is different to the 1 hour data point. And again, when we hit the 1 hour time, we save the data point, data point, data point every hour after that. We do capture this extra data point. That is also where we capture the time waveform or the vibration spectrum, which is this. And this will help the customer find out why the vibration crossed the point. So we often can diagnose here vein pass frequency, which will tell us, and then the shape of the graph will tell us if it's deadhead, run out, or suction. We can tell the three different by this graph. And we capture that at this point. So what this shows you is that the alarm levels are very important. If you had a value here, and your alarm level is very high, if the vibrations spike, you might not capture it. So for customers, we recommend, like if I'm talking to a customer with a lot of sensors in the site, we will say let them run automatically for 30 days. And then after that, we lower all the alarms to be above the top of the trend. That way, if there's any sudden change, you capture it and you get the time waveform and you can try and identify what caused it. I'm going to skip the pressure one because the pressure sensor is not available in Thailand. It's not available anywhere outside of America yet. So this slide just shows you how the data works. So currently, if you were to collect data from sensors, you can use a person with the app. If they have a cell signal, that information goes to the cloud. This is an Amazon cloud, so it's a very secure cloud. We can provide information for the customer if they want to know data security. So that's the way it goes. From there, anyone can view the data from the cloud, but this requires a subscription. The gateway bypasses this person. Because you bypass this person, you can only view the cloud information from the desktop PC. We can connect to the customer SCADA system. There is many ways we can do that, many ways. We can go from here to the gateway straight there. But the best and the simplest way and the easiest way is often to the cloud and connect straight across. But we can do whatever the customer wants, but it just changes the price. If the customer wants to go straight to their system, you need to think about this. If they bypass the cloud, where are they going to store the data? Over here. So they need to have enough infrastructure, IT, servers, everything. And if they have policy on data saving and automatic, that's all for them. Which is why we can do it cheap, because we don't want to deal with that. That's up to them. But their IT department, sometimes that's what they do. So if they have all this data going somewhere, then they need to also, if you have data going to a historian, what's the next thing you need to do? You need to display it. So the other thing, the customer, if they bypass this cloud, they need to take that information, turn it into a graph, turn it into a screen so they can see it. Otherwise, it's just going. And it would be raw data, maybe that's what they're happy with. But if they want to display it, then they need to do that themselves. And we can give them suggestions and things. But the platform stores it and it displays it in a very helpful way. This is perfect for vibration analysts, the way it's stored. It's set up for a vibration analyst. For anyone who's going to do troubleshooting, root cause analysis, that's what this is perfect for. With the gateway, eliminating this person, this is continuous monitoring. So we now make the system from offline to online. As soon as one of these sensors goes in alarm, it sees it, sends it to the cloud. If it's set up correctly, it will send you an email notification straight away. So we can pick up alarms very fast now with the gateway. So customers who in the past may have wanted an online system, that will get them there easily. But again, just bring the inquiries to us and we'll help you work through it, because it's pretty new technology and new methods. It's an example of what the gateway looks like. So it comes in a little box, it's got a modem in it, things like that, power supply. So we'll be making them all different hazardous area ratings. The most common way to use it is with a SIM card, but the customer can connect by Wi-Fi or network. So for the platform, still got internet, that's good. I think rather than showing you the slide, I'll show you the real thing. There's no sound. It's just website. So I'm just going to show you Vodafone Australia because I'm working a lot with them at the moment. So this screen, when it first comes in, shows you the overall site. And you can see here that we have a 3-tier system. They got their 2 locations, one in Sydney, one in Darwin. And at the moment we're seeing all of it. So in all sites have got 45. If I went to Darwin, I think they've got 7. So that shows you the status of 7. And it lists them down here. Go to Sydney, they've got 38. But I remember the pump number. Okay, so if I wanted to then look at one piece of equipment, you can see here that the last time this was connected to was 14 days ago, so it tells you a little bit of a summary. You click on this. Now, we distinguish between asset names and sensors. This is the asset. This asset can have multiple sensors. So it's important when we set up with customers that we understand that that is the asset, and every sensor that goes on there is assigned to that asset. This gives you the ability to have multiple sensors on one equipment. This particular equipment only has one, but sometimes you'll have 2 sensors, 3 sensors, and then you can have all the graphs from one asset on top of each other. Works very well. Actually, I have a customer one customer's got 3. One on a pump, a gearbox, and the motor. That's one asset, but 3 sensors. So here, we can see the trend, but I know they have problems in the horizontal. If I go to the last 3 months, so this shows the alarm levels, where they've been sitting. And we've been crossing this at certain points. Every time we cross, we get this additional data point, but see down here, this triangle, this is the alarm triggered vibration spectrum. So if we want to look at that, we click on it. And it will scroll down. And it will show you the vibration spectrum. So as we move along, we can see that the very big peak is happening at 43 Hertz. Now this pump's on a variable speed drive. That's why it's not exactly 50 Hertz or 25. But we have this value we have this cursor called harmonics. We can pick this, and then if we know that that is the 1 times, put it on to 43, and then we can look at the other peaks. So here you can see this one hits on the 2, and there's another peak on the 5. So we know that all those peaks are happening at the same frequency as the revolutions, but just multiples. So 1 times the revolution, 5 times the revolution. So this is a 5-vane pump. So every time the impeller spins 1 time, it passes the cut water 5 times. That causes a little vibration. So again, that's 1.22, that's not too bad. So the vibration peak is happening at the 1 times. If I scroll down, I can see the time waveform, and the rotations are there. So this is 1 rotation, 2 rotation, 3 rotation over the time. So this helps the vibration analyst determine what's going on. Also in this area, we have critical information. So this says 2955. What actually happens is, I'm going to turn the harmonics off. Right now we see down the bottom, the data is in Hertz, which is rotational frequency. If I change to orders, it puts numbers down here, 1, 2, this is the number of revolutions. This is based on this value here, 2955. So if I put 1455, it changes this. So now instead of being at 1, I'm almost at 2, because I changed the running speed. I need to put it back so the customer doesn't see. The other thing that's in here, it's not all populated yet, but driver information, equipment bearings. See, these are all bearing information. If the customer populates this, in the future, this website will tell them what the cause of a problem is. So there will be a requirement to be able to do this, but the system will automatically tell the customer what is the problem. Vane pass, alignment, whatever. It will do the analysis. That is expected to be out by the end of this year, at least 1 or 2. Actually, some of them even sooner. So I think it's a bit better to show you how the website works. Now, if it's a Gould's pump, like in this case it's a Gould's pump, the bill of materials is in there. Customer can add documents, they haven't added any. We can get the curve. And that's because it's a Gould's pump. Serial numbers in there. If the customer, it's one of their pumps, it's not a Gould's pump, they can put the same things by adding a document in. Now the other thing is, in here, there's the ability to add a note. So if I was to study that vibration spectrum and make an assessment, see my mouse has got a plus symbol, you know, I can add a note. Symptoms, any note you want. I'm not going to do that today. So you can add information on there, and then anyone else who comes on can see that. So it's a way to work together as a team, or have remote people come in and view. Okay. And then the other thing is routes. Routes can now be created on the website. You create the route, and then you can force it to a user to go and do it, to go and collect the data. So someone could be managing this and then ask someone else to do the route. Like, so here, the person that created it was Tim, and it's been assigned to someone called Kian. So he has to go and do the route. It appears on his phone to go and collect the data. Now, if you have the gateway, then if you imagine the gateway is continuously picking up information from the sensor. So each iAlert is always sending out the status, red, yellow, or green. Also, it always sends out the last vibration reading, always. Your phone, you can't see it until you click on it. But the gateway will see it, and it will put it straight in here. So every hour when a new piece of data is provided, it will just appear here. Now, I've got some sensors where, see how I see this detailed trend? Then all of a sudden you'll see a flat line and another dot here, like somewhere else. That's usually because the mobile phone has picked up that single point of data and no one's picked up the trend yet because you've walked past it. Some sensors have that happen. Customers or people go to me, why is the trend all like this? And then all of a sudden there's a flat line. When you move around, you'll see one point here and then the next point at the very end or something like that. Because someone's walked past it, the mobile phone app was on, send it to the cloud, just a single point. If you want the rest, you download the trend, fills all the data in backwards. But the gateway will automatically do that. It's automatically sitting there, picking up everything in the area. The range on the gateway is about 80 to 90 meters. Your mobile phone is 10 to 30. The reason your mobile phone is so short is because the antenna in your mobile phone is very small. The antenna in the gateway, Bluetooth antenna, is full size, designed to pick up maximum range. So we'll get 80 to 90 meters, and we already are in some of the test sites. And we'll even go through some walls and things like that. Pretty good. Sometimes we get intermittent transmissions when there's a lot of interference. If there's too much, it'll block. Now, a tank terminal, for example, where I'm working with a couple of customers' iAlerts, it will not go through the tank.
Yeah.
But it'll do all the straight lines either side between the tanks, quite a good distance. And it's different to Wi-Fi. Wi-Fi will not send signal through a steel mesh fence. Will not. It's like a Faro cage, doesn't do it. But the Bluetooth will. It will go through it. So the technologies are different. There's positives and negatives on each. We chose to use Bluetooth because of the low energy, and just happens that it's got different advantages. So the competition. You know what the competition is? I'm not allowed to share this with you, but I can show it to you. So I'll just run a couple of these. So battery life. We have, this is our iAlert 2, the blue one, and this is the iAlert 2 version 3, where it's got the orange base. So you can see that a lot of our yellow, we made green. We improved the product to be better than the rest. So this is the ABB smart sensor. Might zoom this in a little bit. I think it's a bit easier. This is the ABB smart sensor and the flow-serve beacon. So they have a 4-year battery life on the beacon, but they have a 2-year battery life on the Bluetooth one. Right? So it's less than ours. There is another company that's just come out recently in Europe, and they are saying 5-year battery life. But if you read the fine print, it's 5-year battery life if they save 1 data point every day. Whereas we're doing, so you have to be careful when you're comparing the competition to look at the sample rate. This memory, like this is all needs to be compared at 1 hour. So these battery lives are compared at 1 hour data sample rate. But we still check every 5 minutes. We check the alarm every 5 minutes. We record every hour.
For the data sample rate, I can change in the app, right?
Yep.
Okay.
And when you change it on the app, it warns you about the battery.
Oh.
If you make this setting, your battery life is expected to be 2 years, so no customer is allowed to complain. I had one person in Australia, a sales engineer. We had an eye alert that we increased to 1 minute. And then he put it to sleep because it was just for troubleshooting. We used it 2 or 3 times. Turn it on, put it on this pump, get 2 days worth of data, put it to sleep. So we didn't use the battery. But then we needed to use it for something else. So he put it on another pump and we forgot that he left it for 1 minute. It died after 1 month and 4 days. But so I'm happy. I said, hey, you had 1 minute. I could tell because I went to the website and I could see every single minute I had a piece of data. So we knew that the sample rate was up. But it worked very well for what it did. So the battery life is good these days. See, everyone does vibration. We do runtime. No one else does runtime. We do FFT and time waveform, which is vibration spectrum. So this runtime is us calculating how often the pump is running. We can tell the difference between the pump running and not running, and we give you an hour. The reason we like this and we've used it is Pfizer, who's a pharmaceutical company in America, they use the runtime to determine when to change their oil. Because they didn't really have any record of how often a pump turns on and off because it's connected to a batch control system. And maybe the batch had sufficient volume that the pump doesn't need to run. But then sometimes it hits a level and the pump turns on. They don't know. So this calculates the hour. So they actually managed to offset the cost of the eye alert with the amount of oil they save. So that's why we keep that feature for one customer. But you notice the other thing we do that no one does, FFT and time waveform, which is vibration spectrum. That is like getting a photo of the vibration when you cross the alarm. I don't think there's anyone else successfully doing that. The other thing is frequency range. We now have the best frequency range listed, just by a little bit. But the important thing to note is the effective frequency range. We publish this frequency range and we measure that frequency range accurately. This is the ABB product. It publishes 6 to 1000 Hertz, but it's only accurate 25 to 300. What actually happens is that at a certain point, there's a resonance in their structure. If you've seen the ABB, has anyone seen the ABB vibration sensor? It's about that big. So they get a vibration like it's shaking at a certain frequency, which means the accuracy goes right out. So it's no longer valid. Flow-serve beacon, we've tested it, and they say 6 to 1000 in 3 directions, but they can only do 6 to 1000 in the Y direction, not the X and Z. They can go up to 500. Again, it's just we've tested it and compared. We put them on our test beds and checked it. The error, see the ABB has an error of 200%. So it's twice 200% error at a certain frequency. So if you have a vane pass frequency happening at the resonance frequency, then this thing is going to give you very incorrect values. The error on the beacon is about 40%. The ITT one's 10, within 10. We meet the tolerance and that's it through the whole range. IP ratings are pretty similar. The Flowserve beacon has better gas rating, but if we needed to do that, we could do that. But there's not much market for it. Cost-wise, the beacon tends, look from it, on the internet, these are the advertised prices. Beacon is the highest, but what they really sell it for is lower. We're seeing 280 to 300, whereas we're usually at the 350, depending on. So price is something we're looking at, but you know it's going to have to be based on customer. And anything else? So the iAlert, just one thing. In the past, especially 3 years ago, we used to say, no, we can't do that, no, we can't do that, no, it doesn't happen. Now we say yes. Almost everything is yes. You know, there are limits to technology, but mostly we can start to adapt and say yes.
So if in case that we need to increase the Bluetooth length, so what equipment that I have?
The gateway will increase the Bluetooth range.
Yeah, the gateway, right?
But the limit is then Bluetooth. Bluetooth 4.0, the transmitter is Bluetooth 4.0. The maximum range is 100 meters.
100 meters.
Yeah. Low energy Bluetooth can send 100 meters, that's it.
Yeah.
But
I think enough.
Bluetooth 5.0 is coming out.
Oh.
My mobile phone already has it, but there's no sensors to pick it up. We are developing that. When that released, 3 times the range.
Oh.
Easily. So the gateway, it's going to be Bluetooth 4.0, but if the low energy signal is stronger, it will still pick it up. Yeah. So it will be able to get the bigger range. Surprisingly, we've needed less gateways than I thought we would to pick up bigger areas. I thought maybe we would need one every 50 meters or something like that. We can get away one every 150 meters, which sometimes from some plants that's enough.
Yeah.
One. But it does depend on the interference. So if you have any problems with other brands' products,